In this video, we're going to be looking at alternating series. So what an alternating series is exactly what it sounds like. It's a series that alternates signs. And we just have to be careful about how we think of these because they do switch back and forth between positive and negative, and so that will mean that some of the conclusions we've come to before won't necessarily hold true for all of these problems. So the test that we use for alternating series is called the alternating series test. And it says if the sum of the series is greater than 0, then, and notice this is just any series, this is not alternating signs yet, then the version that alternates signs of that so you'll notice that this one would start with the odd terms here would be negative, and on this one the even terms would end up being negative. So they're saying no matter which way you have the signs alternate, then the series will converge if the following conditions are met. So first, the limit as n goes to infinity of the series has to equal 0. So when we do this part of the test, we're going to ignore the alternating signs. We're just going to look at the series itself. So it has to have a limit as n goes to infinity of 0. And then the other is that if you look at a to the n plus 1, sorry, a sub n plus 1, that needs to be less than a sub n. For all n. So basically, as you go throughout the sequence, when you're finding the numbers that you're going to be adding together to find the sum of the series, those numbers should be getting smaller. If either of these conditions is not met, then there's no conclusion. And that's important to remember because when we learned about the nth term test, a lot of people were having conclusions in that one situation where it was inconclusive. So make sure you know in which situation this is inconclusive, and then when that happens, you can't use it. So we're going to do a few examples. And the instructions are going to be the same as they've been for a while now, so we're going to determine whether the series converges or diverges. So we're going to look at from n is 1 to infinity of the series -1 to the n plus 1 divided by n. So for the first part of the test, we ignore the alternating signs. We just look at the series itself, so that's 1 over n. And we see if the limit of that as n goes to infinity is 0, and in this case it is, so the first condition is met. The second thing we have to do is we have to think about if I do n plus 1, is that less than or equal to 1 over n? And that's true if you think about like maybe n equals 4, then we would be saying 1/5 is less than 1/4, and that is true. And so, no equal sign here. That's true. So both of these conditions are met, and so that means that this alternating series does converge. We don't know what it converges to, but we do know that it converges. And maybe you could write, this is the alternating series test. Okay, for the second example, we're going to look at the series -1 to the n plus 1 times n plus 1, all divided by n. So if we start the first condition of the alternating series test, and we'll say as n goes to infinity, we're ignoring the part that has an alternating sign, and we're just looking at n plus 1 over n. And when I look at this, I can see that this is not 0. So I'm going to say does not equal 0, so the alternating series test is inconclusive. That means I can't use it. So that means I have to go back to one of the other tests that I've learned. Another test that we have learned is the nth term test. And we know that when you look at the nth term test, it's a good sign for us if it doesn't equal 0. So we're going to say the nth term test says the limit as n goes to infinity of -1 to the n plus 1. You'll notice that since I'm doing the nth term test, I have to go back to considering the entire series. I can't just look at the part that's not alternating signs. And when I look at this, I know that this part is going to alternate signs, so that's going to be plus minus. But then when I think about plugging in infinity, n over n is going to give me 1. So that's positive or -1. Either way, it doesn't matter because it does not equal 0. And so when we were doing the nth term test, if it did not equal 0, it told us that it diverges. All right, next we're going to go ahead and look at absolute convergence. So absolute convergence says if the series where it has an absolute value sign around it, so we're not alternating signs, we're just saying that all of the sums are positive. If that converges, then the version that is alternating signs would converge as well. So we have two different scenarios here. The first scenario is that the sequence is absolutely convergent, sorry. If this one converges, and the one that alternates signs is conditionally convergent, if it converges, but this other one, when you force it to not change signs, but this other one right here diverges. And since those are very similar, and you have to be careful to notice when you've got one situation or the other, so I would say maybe highlight that to draw your attention to it when you're looking on these problems, because we want to notice those. All right? So we want to go past maybe our initial conclusion about whether or not the specific one we're looking at converges or diverges, and we want to go past that and see if it's absolute or conditional. All right, so we're going to look at some more examples. So example 3, we're looking at -1 to the n factorial divided by 2 to the n. So if we look at the limit as n goes to infinity of n factorial over 2 to the n, you have to think about which one is increasing faster to be able to know if it's going to be infinity on the top or infinity on the bottom. So if you think about the bottom, this is multiplying by 2 repeatedly. The top multiplies by 2, then 3, then 4, then 5, then 6, then 7. It multiplies by bigger and bigger numbers. So that means the top multiplies repeatedly. And then that means that this is going to equal infinity, not 0. So we're going to say does not equal 0, so the alternating series test is inconclusive. However, that does mean that we can look at the nth term test. And we're going to see from that that the limit as n goes to infinity of -1 to the n factorial over 2 to the n is going to equal positive or negative. That's the alternating series part of it. And then we're going to see that that was infinity on the top, so that's plus or minus infinity. And that gives us the conclusion that this would diverge. So we use the nth term test to determine that. And then, of course, we're not going to check what type of, if it's absolute or conditional, because it diverges, so we don't need to look at that. So our fourth example, we're going to look at from 1 to infinity of -1 to the n over the square root of n. And if you do the alternating series test, you're going to find the limit as n goes to infinity of 1 over the square root of n is 0. So that part of the test checks out. And then if we look at 1 over the square root of n plus 1, and making sure that's less than 1 over square root of n, if you think about your n being 1, then you'd say 1 over 1, and this would be 1 over the square root of 2. So 1 over 1 would be greater than 1 over 1.4. Definitely true. So both of those conclusions hold. So that means that this is definitely convergent. And then we have to determine whether it's absolute or whether it's conditional. And we do that by ignoring the alternating series part and just considering the series from 1 n equals 1 to infinity of 1 over the square root of n. And if you look at this, you might recognize that this is a p-series. And the p-value here, we could rewrite this as 1 over n to the 1/2. So the p-value there is 1/2. And when you have a p-series, if the p-value is less than or equal to 1, we say it's divergent. So while the alternating series version converges, if it wasn't alternating series, it would not. And so we're going to say that this converges, but it does it conditionally. It really only converges because those signs are alternating. All right. And then our last example, we have from 1 to infinity of -1 to the n plus 1 over 3 to the n. So if we look at the limit as n goes to infinity, and we're not using the alternating series part, we're just looking at the positive version of that, then we're going to say, yeah, that's definitely 0, that limit is 0. So the first condition of the alternating series test has been met. And then we'll consider what happens if we compare 1 over 3 to the n plus 1, and we want to make sure that that's less than 1 over 3 to the n. And that's going to be true. This denominator is going to be bigger than this denominator, and that means that this fraction is smaller than the other one. And so both conditions are met. That means that this alternating series does converge for sure. And then we want to consider the part of the series that's not alternating and see if this is a conditional convergence or an absolute convergence. So now I'm going to go ahead and consider 1 over 3 to the n, just that series right there. And if you recognize this is a geometric series, it's like 1 times 1/3 to the n power. And so if we look at that, we would say that this is geometric. The r is 1/3. And since r is less than 1, then we know that that converges. And since that converges as well, then we would say that this absolutely converges. That's because it doesn't matter if the signs alternate or not, it's going to converge either way.